All right. So today's crew, as far as the presentations are concerned, are myself, Bob Elliott. Aaron is actually a Grove City graduate. Aaron is going to be doing some work for you, or is going to be doing a session today as well. And Adam is also a Grove City graduate. And this is B3A. You guys have some material in your packet about us, so please feel free to ask us questions during the break about who we are. Today, what we're going to try to get them across is, first of all, we're going to try to get the good basic fundamental skills of data modeling out there so you guys can learn a little bit about that. We're going to touch on entity relationship diagramming. We will be using Visio 2010, and all of you should have had the installation of the forward engineering on there. We'll be having a section on normalization today. So the data redundancy elimination and the proper do's and don'ts of how to actually design different database models to eliminate redundancy and make things a little bit more efficient. Bob will be doing a course on that. Also, Bob is going to talk about some basic SQL methodology as far as triggers and stored procedures. Many of you had the data modeling class or the database management class last semester, so some of this will be some review, but hopefully you'll come across with something. And we're going to start wrapping it all together, and we're going to show you where do you go after the databases are built. We're going to touch on a concept that is the data access object layering system. So how do you actually take these data models and put them into your systems? We have a couple of sections on a sort of a roll your own type of a thing for that. How we can build a code to build the fundamentals of using these things. Then we're going to take it and pull it all together, and we're going to show you some techniques on how to actually implement these into websites and things like that. Aaron has a nice demonstration at the end on that. Okay, today we're going to be conducting 5 lessons, 6 lessons, 5 labs. We will be doing the labs, which are, they can be individual. If you guys want to team up, work together on these things, might not be a bad idea. Again, today's an opportunity for you to relax, enjoy yourself. If you want to work as a team, that's fine. If you feel more comfortable working on these individually, that's fine too. They're self-contained labs, so everything that you have should be able to be doing on your own laptops. There's nothing that you'll need to get onto the network today in regards to, so you could do these later on anywhere. Please feel free to make this a two-way conversation. If we have any kind of piece of information that you don't get, please feel free to raise your hand, and we'll put it on the discussion. The agenda, okay. Again, that's in your you refer back to this all day today. We can be flexible with this if you want to spend more time on a lab, or if you want to spend more time on a lesson explaining some things. Again, this is your seminar, so please help us guide through that. Okay, so we're going to start the first lesson. We have a couple of videos that we have that go over some basic fundamentals of data modeling. So we're going to start off showing you a couple of videos.
Before we write a single line of SQL, we should have a good idea of exactly what we want to do with our database and what our database should look like by the time we've finished creating it. We should go through a process of planning or data modeling before we start implementing our solution. The question, where do we start when we're about to create a database solution for a particular problem, is best answered that we should first of all understand the nature of the problem. We should look first to the real world needs or problems that have created the need for the database. Sometimes it'll be just us who needs to use a database, and therefore it's simply a matter of getting our thoughts together on paper or in our heads or however we wish to do it. More likely though, we'll be designing a database for a number of people, all of whom have an idea about what they want to get out of the database, and this could be such a diverse range of people as the head of the organization, the programmer who is going to interface with our database, the end user, the person who is going to provide technical support to the end user, the customer, and so on. So it's important that we consult everyone involved and get a good idea of what their opinions are as to the needs that underpin the creation of the database. It's important that we analyze the problems that underlie the needs for creating the database in the first place, and that we have a set of objectives that everyone has agreed upon and that we can go forward to implement. Once we've done our consultation and we've talked to all the relevant people, or if it's a very small project just involving, say, yourself or you and one other person, had a chat or even just sat down and had a think about it, it's time to start getting a little more concrete about the way in which we want our database to be structured. I like to start putting things down on paper from the earliest opportunity. And this doesn't have to be in a very structured way at all. I like to use a simple brainstorm, just a scribbling on a piece of paper, to get some ideas down as to what I think I need to include within my database. There's no particular logical right place to start here, just want to get as many ideas down on the paper. I'm taking as an example the library database that we looked at in the last movie, and how I came to come up with that particular set of tables. I knew that I wanted to center the library database around the books that contained within it, so I wrote the word book on a piece of paper, and then I simply drew lines out from that central point with all the other relevant elements I thought should be present within the database. Of course, this is going to be a very scrappy process, one which you may bring up at least as many questions as it answers. That's the whole idea behind a brainstorm. You may find that you add elements which you later realize that you don't need to include at all. That's all fine. Part of the process is making the mistakes early so that you don't make them once you've implemented within your database, and then you have to worry about programming, taking data from one place to another, and all these other kind of hassles and nightmares. It's much better to make the mistakes on the drawing board and get them all ironed out as much as possible before you go to implement your solution. After we've got a general idea of the kind of things that we want to be doing in a brainstorm or however you like to do it, it's a good idea to map out the concept behind whatever application you're using for your database, or for your database structure for that matter. You may need to create a few of these to make concrete some of the ideas of what you're wanting to do with your database system. For instance, this one is a simple diagram that illustrates the way in which I want to run a search query on the data. I want to be able to search by title, author, ISBN or publisher, and I want it all to have the same result and come back as the results of my query. So a simple diagram, even as simple as this, will help to solidify in your mind exactly what you want to be doing. It's at this point that you can start getting technical, by which I don't even mean writing any SQL yet. We're still several stages away from that. Now it'd be a good idea to create an entity relationship diagram. The idea of entities is a common one across various different disciplines within programming and software design. If you've done any programming before, you'll be aware of the object paradigm and the structures of object-oriented programming. With a relational database management system, our entities are rather different to the objects within object-oriented programming languages. However, they do have some similarities. Each of the objects should be a single item within our database, and we should try to stick as closely as possible to real-world entities. For instance, we may wish to create an entity called a book, and in general, our entities within our entity relationship diagram will translate directly to tables within our database. There are some specific ways to create an entity relationship diagram, some ways of drawing lines to represent the relationships between entities. You can follow these if you wish, or you can use your own method. It doesn't really matter. So long as you understand and you're consistent about the way you're laying out your diagram, that's the main thing. Most important thing about entity relationship diagrams is that all entities that are going to be included within your database are mapped out in your diagram. For instance, we may have a book entity and a publisher entity. We also need to specify the exact way in which they relate to each other. We draw lines between each of the entities that relate to each other, and then in some way we annotate these lines to show the particular kind of relationship it is. It's usual to put a crow's foot or extra little lines there if we want to show a one-to-many relationship. If it's a one-to-one relationship, we simply put a single line. We can also use a circle to indicate that the relationship is optional on the part of one or other of the entities. That is to say, a publisher can exist within our database that hasn't published any books yet. This allows for all kinds of different theoretical eventualities. We put the circle on the side of the book because the publisher can exist without the book, but no book could exist without a publisher. Similarly, we put in genre entity within our entity relationship diagram. However, there's a slight difference here because genres can exist for which we have not yet entered books into our database, but we can have books that defy genre, books that refuse classification. Therefore, I'm including an optional, a little circle there to show that it's optional at both sides of the relationship. However, it's still the same kind of one-to-many relationship. One genre, many books. We could go further and complicate that to say that a book can cross between two genres, but I think that's better exemplified by the author entity. Now, we could simply put a one-to-many relationship there or between books and authors, but that would only allow books to be written by one author. Now, that is not a rule that we can impose on our library, especially if we're going to be using technical or non-fiction books, many of which are written by more than one author. In order to represent a many-to-many relationship, as in any number of books can be written by more than one author, we have to use a bridging table. I've called this book author, and this is a way of implementing a many-to-many relationship in a way that can be used by our relational database management system. If you take a look at the SQL schema that is included in the source folder on this CD, you'll be able to find the particular tables that are included within this database. Finally, once you've made your entity relationship diagram and you're happy with the way it looks, then you can start to draw up your SQL schema. you'll find that as you implement each of these steps, as you draw out more and more technical diagrams and finally create the SQL, you'll find that you'll be constantly refining as you go. So you may draw up a first initial draft of your SQL schema, and then you may find that you will refine it, create different tables, alter the structure of your database, and so on. This briefly sums up the process by which we get from the conceptual point of the process to the actualizing of the database. In the next movie, we're going to look at normalization.
Okay, can we have the lights please, Bob? Okay, there's a couple of things that I find that as a really good starter for this conversation today. There's a few things that I want to sort of highlight from those videos, and one in particular is the brainstorming process itself, okay? It's incredibly important that one of the things he said that I think you want to take home on this is it's okay to make mistakes early, okay? And in any kind of a software development project, making mistakes early and correcting them early in sort of the conceptual phase, turns out to be highly advantageous to your project for a lot of different reasons. You're going to have a much higher quality product at the end, and it's also going to be something that's going to be advantageous from a cost perspective as well. There have been many studies that talk about the amount of cost involved in removing defects downstream of the life cycle methodology. How very expensive it is, and you think about it, you find out that your design of your conceptual model was off. Now you've got all your code written, you got all your UIs, you got your screens written, and now boom, you got to go back and make gazillions amounts of changes. Okay, so the brainstorming process is incredibly important. The way the gentleman speaks about it, it's sort of a scrappy process that you want to sort of kind of get everything down on paper, make simple diagrams. And another thing that he brought up that was valuable was bringing in outside consultants, analysis, using the people that know the model that you're trying to design. That's another very important key as well. And what we're going to be doing in the lab is we're actually going to be doing a brainstorming session. We have today's exercises are going to be centered around something that you're familiar with, so hopefully it'll be sort of easier for you to work with. It's going to be a class scheduling system. Students, professors, buildings, classes, rosters, things like that. So it'll be something that you're familiar with. And we're going to be using that as our base example today, and we'll go through the brainstorming process during the lab today. And then we moved on to a few things about the entity relationship diagrams. Okay? A few of the things that our gentleman pointed out was that, again, these are single items that need to be looked at as real-world items. We talked a little bit about object-oriented programming. It's slightly different in regards to you can have a few things sort of combined together. You want to look at sort of the smallest grain that you can and consider that as the entity that you're going to look at. He talked a little bit about the standardization. I personally differ from his comments in regards to where he said something to the effect of just pick some kind of a notation that you feel comfortable with. That may be appropriate if you're designing the system yourself and the only person that's going to be doing is reading this. But I would counsel that you want to probably pick some kind of a standardization when you're talking about the relationship lines that you're drawing. So instead of just drawing a line and making up some kind of a notation that you feel comfortable with, I would suggest using a couple of different notations. The crow's foot is what he discussed in here, and then there's a Bachman diagram, which is probably a little bit more familiar with, that you might have seen in some of the tools that you're using in Visual Studio and things like that. The crow's foot is more, sort of widely understood, and the concept of having the single line drawing to the multiple lines. So if you have the 3 lines that are coming out, that would denote the many concept, where a single line back to the entity would denote the single entity. So a one-to-many is kind of understood in the notation of the crow's feet just by the fact that, it's easier to see. Okay, I have multiple lines entering this box, and I have a single line coming out. So you have a one-to-many kind of a notation there. So we tend to use, at B3, we tend to use the crow's foot notation, and I've seen that kind of all over the place. Now, what I've done for this particular slide is to just give you, like I said, there are many different kinds of notations. And as you can see, the Bachman notation is the 3rd one down that you might be familiar with when you see things in Microsoft or Visio. That's the default that they give you. I've seen some of your diagrams that you've generated for some of your classes, and by just using Visio out of the box, you tend to get that. You actually have to go in and change a setting to do the crow's feet, and we'll show you that in a moment when we do the demonstration. The crow's foot is the one down, I believe, from that. But here is a series of various different kinds. For your references, the different notations, and please feel free if you want to sort of learn about these to kind of go off on your own and do that. But we're going to focus today with the crow's foot notation. Okay. Now, there's many different kinds of relationships that exist, and the common ones that you're going to see is the one-to-one, and there's some concept about that is why would you do a one-to-one, and it's basically maybe separating some logical entities, because in reality a one-to-one is essentially information that's the same, and the parent-child relationship on a one-to-one would be as if I don't have any information. It might be a good way of not keeping a record. Excuse me. Not keeping a record of actually putting a record in a second database, so that you could save some space that way. So if you do have logical divisions between your relationship, you could build a one-to-one, but it strictly means that you can't have more than one item in the second table. And the same thing with the 0-to-1. It just means that you can have an optional situation in the first column. A one-to-many or 0-to-many is more familiar. If you find yourself building many-to-many relationships, okay, this is sort of a keeper here, you're probably writing the model incorrectly. If you look at your model and you see many-to-many relationships, you're probably not designing the model correctly. Okay, that's a relationship that's very difficult to manage. It's illogical, and what people tend to do, as you notice that he said, you use a bridge table. So you want to put in between the many-to-many relationship, a one-to-many into an intermediate table. I think the example he used was authors and book, where the relationship would exist in your brainstorming session, where you could say, well, I have a many-to-many relationship. An author can create many books, and there can be many authors on a single book, so hence a many-to-many relationship. However, when you're building that physically, you're going to want to put a book author intermediate table or a book author bridge table in between to manage that relationship. Okay, and I think we might have a couple of examples of those in the session, so keep that in mind. Okay, that's the point of this slide, is really trying to drive that point home. One other kind of concept that he brought up, that when you think about it, it's kind of difficult to comprehend is remember he said the zero or the open circle at the one end means optional. You can kind of think of a 0 or an O as optional in that case. So in this particular case, we have a one-to-many relationship, and there's optional objects at both sides. We have a dependency on the course has to be, or it may be assigned to a department, or it may not be. Maybe it's an experimental course that is not assigned to a department yet, something like that. You know, just hypothetically say that's the situation. I don't know if that really exists, but that's the situation. And you might have a department that's created that may not have any courses yet. So that's the concept of it, but in the physical world, you're really not going to have a situation where once you put a department in, that you either have to have no course yet, or you're going to put a course in later. You know, so that optional concept at this level right here is kind of implicit. You have to insert a department if you have this relationship. If this doesn't exist, if you have to have a department in building a course, then you have to put the department in first and then put it in. The only time this kind of can exist is if it's at both ends. You cannot really, technically in the physical world, have this O be eliminated and this O be existing, because that means that in order for you to put in a course, you have to have a department. And so implicitly it exists. You have to have a department first. It's the chicken and the egg thing. Okay, does that kind of, did I confuse anybody, or are we good with that concept? Okay. A lot of these things are for conception purposes, and then when they go into that particular concept is for conception purposes to how I define the relationship and the key for when it physically builds it. Okay, so we'll move on. A parent has a child. Okay, so here's a required relationship, and this is what I was talking about. We have a required relationship that says that we have to have a student before we have a course offering, and we have to have a course, and then we can have a course offering. So here is a notation of a bridge environment where we have course offerings. So the students actually sign up for courses, and then there's a course that's out there. So we have to have we can't build one of these things if they don't exist. So this is an example of a required relationship. And again, it's denoted by the fact we have no circles on there. Okay? The bridge table many-to-many, this is what it looks like in a physical environment. This is what it looks like physically on paper. We have a book, we have an author, and this is just a review, a reiteration of what was already said. So now we move from the physical world, the relational diagrams, and we're moving towards the physical world. Okay? The entity relation diagram, translating into scripts, you're going to build tables, primary keys, foreign keys, and there are several different kinds of tools that you can use to actually move from the drawings into the actual physical. You know, the gentleman in the video, he actually typed in all that create table stuff. Okay, what you're going to see today is that we can use some tools that will actually allow you to move forward and generate the code for you. Today in particular, we're going to be using Visio, where we can draw the actual entities and the boxes and put the information in and put the columns in and the constraints and all the requirements of the relationships, and we'll be moving forward with the actual physical create statements, the actual physical SQL scripts via a tool called forward engineering. There's another thing that later on in today you're going to be looking at. It's called Entity Framework. Entity Framework is Microsoft's newest or most recent modeling. Andy's going to talk about that later, so I'm not going to steal a lot of his thunder, and it won't mean anything until we get there anyway. But it's essentially taking all of the physical layers, and you can draw and design in their tool, and then you can generate code that actually will build either a script for SQL, or you can actually build some code that will actually let you access it. There's another product out there, if you run into this, if you ever do any Microsoft or MySQL work, that you're probably going to want to sort of put on your list of things to look at, the MySQL Workbench. The MySQL Workbench is sort of an all-encompassing tool that will allow you to generate the entity relationship diagrams. It will allow you to reverse engineer any database into entity relationship diagrams, and it will allow you to forward engineer the information directly either into scripts or directly in, and it'll generate the database objects for you if you point it to a database. It works only for MySQL. Okay, and there's other.
And it's free.
And well, there's a version that's free. Yes, it's free. There is a commercial version where you can get some support, but it's actually there's a free version out there. So if you ever have a project that uses MySQL, I encourage that you look at the Workbench.